Hello everyone! Another theorem for triangle similarity is called the basic proportionality theorem. This theorem came into being when there is a segment drawn parallel to one of the sides of the given triangle, making two triangles which are supposed to be similar. Just like in item number here in practice exercise, just like in the problem here in practice exercise A. We are already given that segment EA here, the blue colored one, is parallel to segment MG. The basic proportionality theorem tells us that the segments here cut by the segment EA are now proportionate to each other. That would mean SE over EM, the segments cut, are equal, or their ratio is equal to SA over AG. Okay, that would be the consideration when this is segment is parallel to one of the sides. However, please do not assume that this is also proportional to EA and MG. Okay, it's not. Okay, because these are just the segments. These are not sides. These are these SE and SA are sides of the smaller triangle, but EM and AG are only this area here. They are not sides of a triangle. So we cannot assume this. What you could actually do here is again this one. Yes, once that we are assured that EA is parallel to MG, we can come up with this relationship. But for the two triangles here, it's still on the relationship between the whole sides. To do this, you may break that up. Okay, I'm not really that good here. And so you have S E A and you have S, sorry for that, S M G. So this again are for the segments, but for the whole triangle, the two triangles, it's SE over SM is equal to SA over SG equal to EA over MG. This relationship are for both two triangles. Take note that it's SM the whole side, not EM only. And it's SG the whole side here, not just AG only. This is what we are going to use later on for checking. But the basic theorem tells us that we could use this relationship for segments if we have one segment parallel to one side of a triangle. Let's do that. SE is x over 3 is equal to SA is 12 over y. But we have two unknowns now. Okay, we could actually use this relationship to solve for the unknowns. We could solve this problem in two different ways if you want to, but we could actually use this here, as we all know that SM is 12. So if SM is 12 and EM is 3, we know that X should be 9. Therefore, the first solution, X is equal to 9. Right? How do we do that? Here's the solution. SM is equal to SE plus EM. So SM is given to be 12, SE is X, plus EM, which is 3. So X is 12 minus 3, which is 9. This is the first answer, and that is what we're going to substitute here. 9 over 3 must be equal to 12 over y. 9y is equal to 36. So y must be equal to 4. Okay? Y must be equal to 4. So we have this result for x and y. However, to solve for z, which is the whole side of mg, we will also use the whole sides here. So we will use this relationship to solve for z. Okay. Why? Because again, em and ag from this statement are not sides, but they are just segments cut from the side. So we will use SE here, SE, which is given to be X over SM, which is 12, and pair it with EA. EA is 18 over MG, which is Z. But X is again already given as earlier as 9. So we have this solution here, 9 over 12 must be equal to 18 over Z. Fundamental law of proportion, you have 9Z is equal to 12 times 18, though a bit large, but we can still compute it as 216. And then when we divide both sides by 9, 216 divided by 9 is actually 24. So these are the results for the unknowns. But we need to check whether it's correct or not using this checking here. This proportion, again, when we check, we will not use the relationship brought about by the basic proportionality theorem, but we will use the relationship for two triangles form. So we have SE, okay, SE, which is again X over SM, which is 12 as given, must be equal to, this is checking already, which SA, which is 12 over SG. G is Y is 4. So SG is 12 plus 4, which is 12 plus Y. Let's do this first. Let's remove the question mark first because we have not substituted anything yet. And then EA, which is 18 over Z. So X is 9 over 12. This is the time we will use question mark. 12 over 12 plus 4, question mark, 18 over Z, which is 24. So you have 9 over 12, question mark, 12 over 16, question mark, 18 over 24. 9 over 12 in lowest terms, 3/4. This is also 3/4 by 4. It is also 3/4 by 6. Question mark. That means the value for x, y, and z satisfies the two triangles. Okay. I would like to repeat my instructions earlier. The basic proportionality theorems allows us to use the proportion of the segments here. So x over 3 and 12 over y. But for the remaining side, we will use the relationships of the sides, proportional sides, not just the segments. Okay. But as to the question, which we could ask as to the question whether this proportion of sides could still solve x and y even without using a basic proportionality theorem, the answer is still yes. It now depends on you on which you will use. As long as once you check, it could satisfy and create the same ratio of similarity. Okay, we'll have next videos soon. So please practice on this as we prepare for our exam. Goodbye.